Hello everyone, welcome to Civil Mania. So in today's lecture, I'll be telling about how to go beyond the grid lines. That is, in my previous lecture, I have told about how to create the grid lines. So in today's lecture, I'll be telling about how to what to do after creating the grid lines. Suppose these are the various grids I have created here. Now I have to insert the uh, columns as well as beams. So for before that, what I need to do is I need to go to the define section. Then after going to the define, I have to click on material properties. Then after material properties, I have to click on add new materials. After clicking on add new materials, India steel, first let me go to the steel. Means steel, these are the various steel sections, that is IS 800 sections, such as I section says, channel section says, then ISMB, ISMC, then ISHB. All these sections are steel sections. But for the RCC building says, we require, first of all, let me go to the concrete and click here India. Then remember that for the any kind of construction, earlier M20 was going to be used in various books, but now as per IS 456 2000, we have to take the minimum grade for the construction of the building as M25. We cannot take beyond M25, that is lesser than M25 we should not take, because this is I am telling only based on the IS code book, that is IS 456. So minimum grade is M25. So you can take M25, M30, M35, M40. After that you can take any kind of grade. So if you want to create beyond M60, then you have to manually provide the properties. So let me create as M25, click on OK. These are the properties which are created automatically. Simply click on OK. So M25 created. Now let me delete the other properties which are created by default. Okay, I will delete it afterwards. M25 created. Now again let me click on add new property, then go to the rebar sections. After going to the rebar section, let me click two kind of rebars. This is one is the HOSD FE 415. I am going to create only for the 8 mm diameter bars, and click on OK. These are the by default, these are being created. Now this one is I have created already, it was created before. So let me modify this one, or let me delete this one, because already HOSD 415 is present. Let me delete this one and now add new material, rebar, take it as FE 500. Remember that I can do the designing by FE 500 also, and also by FE 550 also. But remember that in SP16, if you are going to do the designing by SP16, then in the SP16 there is only grade present is FE 415 and FE 500, but there is no presence of table for FE 550. But nowadays FE 550 as well as FE 550D grade of reinforcements are also present, so we can select grade as FE 550 also. Now click on OK. After that I have added three material. For this one is for 8 mm bars, and this one is for the 12 mm bars, 10 mm bars, then 16 mm bars, 20 mm bars, and 25 mm and 32 mm bars. And this one is the reinforced, this is the grade of mixed design of the concrete. Now click on OK. After that, after defining the material properties, now I'll go to the section properties. After going to the section properties, I will click on frame sections, and in the frame sections let me delete the multiple properties, such as I will delete here, delete property, because these are created before, so delete it because these are not required. I will now create property, fresh property. Okay, I'll create new property. Let me delete all this property because these properties are not required, because these properties are created by default. So now let me create add new property. After adding new property, let me, for concrete sections you have to click this here, this 4. For steel sections, this 4. For special sections, I'll be telling about what is this special sections, and I'll also even say tell about this composite sections. Here in the composite section there is the combination of concrete as well as steel. Concrete plus steel combine to produce the concrete sections, but composite sections are not RCC sections. RCC sections we have concrete plus rebars, but not concrete plus steel. Steel means I sections, C sections, hollow sections, all this. So now let me create the rectangular concrete sections. Then let me create one column. So let me write as column, and let me write as column, and suppose I will be creating one column of size 350 by 400. 350 by 400. Depth I will keep as 400 and width I will keep as 350. So in this manner the concrete the beam column sections will look like. Okay, after giving these two 400 and 350, now the most important things which you have to do is you have to click here and you have to select the grade of concrete, that is M25. M25 given, column you have to rename as column 350 by 400. You have to specify the grade of concrete. You have to give the size of the concrete member, that is 400 by 350. You can also change this one as 350 and this one as 400, because in columns it doesn't matter, but in beams the depth should be always greater in comparison to the width. After that you need to go to the property modifiers. In the property modifiers, remember, no one is going to tell you in details about this property modifiers, because I have seen various videos in YouTube also, but nobody is going to tell you in details about this property modifiers as well as stiffness modifiers. But this is the only video I'm going to tell here in details, because I am a structural designer and I am working as also a structural consultant in various firms. So I will be telling you everything, even each and everything says in very details. So let me tell you that for the columns what you need to do is you have to keep everything as same. You have to go to the moment of inertia. So for the columns you have to keep the moment of inertia as 70%. So for this you have to keep this one as 0.7 and 0.7. Rest you keep it everything as okay, same. Click on OK. Now after that you have to go to the reinforcement. After going to the reinforcement, longitudinal, see this one is the lateral ties, so keep it as FE415, but longitudinal bars you keep it as FE550. Then you are going to do, this one is the column section, so click on column, rectangular or circular column. I am creating rectangular column. So reinforcements to be checked and reinforcement to be designed. There are two things is, because I will be first of all doing the design, so I will click on reinforcement to be designed. After that, so now clear cover for the confined bars. Always remember that as per IS 456 2000, the clear cover of the column sections is 40, for the beam sections is 25, and for the slab it is 20. So in this manner you can you can even search in Google for the various clear cover, or you can also even have a watch in the code book, because in IS 456 everything is mentioned in detailed manner about the confinement bar spacing, but it's not necessary. Simply remember that for the columns the spacing is 40, number of longitudinal bars along the 3-phase direction, that is 3, and 2-phase bars it is 5, and longitudinal bars are keep as 20, because rest you keep everything as okay, because These all changes I will do in RCDC software. Okay, it's not necessary in Etabs for changing all this. Only you require to change this factor 40 and rest you keep it as okay. After that click on OK. So column section I have created. Now you can delete this one. Now after clicking the column section, I can click on add a copy of property. Simply change as column 500 by 400, then click on 500 400 and rest is already, because I have created the copy from this one, so everything is like modified. See, these are modified, these are also modified, so everything is modified. So simply click on OK. In this manner I can create columns. Again you can create another column. Sorry, not like that. Simply click it here, add a copy of property, then column 500 by 700, then 500, then 700, then click on simply OK. In this manner we can create the columns. After that we can create beams. For that simply click add new property, go to this rectangular, then click here beam. Suppose I am going to click beam as 350 by 400. Depth should be higher for the beams, that is 400, and width should be 350. Click it here. For the beams, the torsional constant will be 0.001 and moment of inertia will be 0.35. Moment of inertia will be half as that of the moment of inertia of the columns. For columns it is 70%, for beams it is 35%, that is half of 70%. And this is the torsional constant 0.001. Remember that most of them will tell different things, but these values, such as property and stiffness modification factors, all these values I have like checked it and I have discussed with one of the professors of IIT Guwahati. So each and everything which I am providing here after consulting with the professors as well as after my experience I am telling you. So you have to simply by heart all these things what I am mentioning it. Okay, now click on here. After that again you can go to modify and show rebar. After that you are designing as this one I am creating as beams, so you have to click on beams. Now longitudinal bars as 550 and ties as FE415. Remember that actually for the beams, see beams, for the beams this is not clear cover but this one is effective cover, because here written cover to longitudinal rebar group centroid. From the centroid I have to take down the spacing. So for that what I will do is, let me go to the paint here. Suppose this is the beam section present here. Okay, so these are the reinforcements which are present here. So okay, so these are the reinforcement present here. If this one is the clear spacing, but this one is the clear spacing, but here we require the effective spacing. And remember that even in the beams the stirrups are being present, so stirrups are also present. Stirrups are present of 135-degree bending. So suppose these stirrups are having the diameter of 8 mm and this reinforcement says, suppose this one is having the reinforcement of 16 mm. What will be the effective cover? Effective cover is the distance from the center, from the edge to the center of this bar. So first of all, clear cover of beams is 25. So 25 plus, this one is the 8 mm bar present, so 25 plus 8 mm plus half of 16, that is 8. So 25 plus 8 plus 8, how much? It's 8 is 16, so 25 plus 16, so this is 141. So in this manner you can find out. So 40. So finally the clear cover, the effective cover for the beams is 41. But before that, let me once again check what is the clear cover of beams. Clear cover of beams, columns. Okay, clear cover of beam, column, footing, slab, everything. So see, for the slabs the clear cover is 20, for the beams the clear cover is 25, for the columns the clear cover is 50, and for the footings the clear cover is 50, as I have told you, or you can by heart this one. For the slabs it is 20, for the beams it is 20, for the beams it's written wrong, as you can see here. This is actually the original value, this is wrong value. You can go to textbook, here it's written. See, for the slab the clear cover is 15, for the beams it is 25, for the columns it is 40, for the footings it is 75. Even you can take 50 as well as you can take 75. So this is how. So now let me go to here. So 25 plus 8 plus 8. Okay, so this one is the 41 value. So let me provide the value of this one as 41. So here the value will be 41, and for the bottom bars also the value will be 41, and click on OK. After that click on OK. So this is how I have created the beam. Sorry, again let me modify it, because here I have created, not clicked on M25 or M30, M25 again. Now again click a copy of beam. Then suppose I am creating a beam of 400 by 600. Depth will be 600 and this one will be 400. Rest everything is already modified, because I have simply I have created a copy of from the another one, previous one. Copy. So this is how I have created the beams and columns. Even now I can also even add another property which nobody will be telling you about. So let me click on add new property. About this function, that is auto select function. This one is auto select. Here click as auto select column. After that go to concrete sections, auto select concrete. You can add everyone and click on OK. Auto select column. Now you can click another property, again auto select. This one is auto select beam. Auto select, it's a function. Suppose I want the software to that software will automatically assign all the members, then I'm going to use auto select. So auto select beam, auto select columns. Okay, now let me go to this here. Then I have created materials, I have created beams. Now let me go to the slab sections. In the slab section, let me delete these two slabs before. Let me add a new property, slab 150 mm slab M25. Then shell thin, shell thick, membrane and layered. These are the various things which I am going to tell you in details. See, always try to make the slabs as shell thin, but remember that if you are going to provide the shell thin, then you have to provide the modifiers for the slabs, such as in the modifiers I have provided in the beams and columns. Even you have to provide the modifiers in the slab. The modifiers of the slab are 0.25, 0.25, 0.25, 0.25, 0.25, 0 up to bending. Okay, up to here I have to provide all this value as 0.25. Shear and mass are not required. Don't get confused. Each and every values I am telling, I have first consulted with the IIT professors, and even I have done the peer review of my reports, and after that only I am going to tell you about these things. So don't look after the values of others, simply by heart this value which I am providing it, because these are very authenticate values which I have provided here. Okay, so now click on OK. Now you have to provide the slab as 150 value. This is the slab. Now click on OK. So I have created the slab. Now I can delete the previous one because now click on OK. Now let me go to the plan view. Okay, so see, let me go to the base. Remember that if you are present at the base level, then at the base level 0 level you cannot create the columns. You can see here the columns, this one is in gray portion, means you cannot create columns in the base level, because in the base level the footings will be created automatically. So first you have to go to the first level, that is plinth level. After going to the plinth level, now you have to click in this one, quick draw columns. Now after clicking on quick draw columns, you have to select here what are the column size you will be providing. Suppose I will be providing the column size as 500 by 400. Okay, I can click here 500 by 400, but before clicking you have to select here whether I am going to provide the column size in all the stories, or for the similar stories, or for only one story. Suppose I will select one story, then it will be created only at the plinth level. Suppose I will click as all stories. Now these columns will be created in all the stories, means at plinth level, at first floor, at ground floor, everywhere it will be created. So I have selected here all story. I have created here column 500 by 400 size. Now click it here, zoom it and click it here. But see, as you can see here, I am not going to create it properly because here snap option is not on. So what I will do is I will again press the escape button. Now I will close everything. Now I will right click here and I will go to snap options. After going to the snap options, select all and apply it. After that I will again go to beam, column 500 by 400, all sections. Now see, I will click it here. These are the columns I am creating. See, in this manner I can create by selecting one by one, or what I can do is I can simply drag it here and I can create. As you can see here, the columns are created automatically by dragging. Now you can go to the 3D view. See, in each and every layers the columns are created because I have selected here as all story. I have not selected a one story, because if you select one story, then only in one story the columns will be created. Okay, after that okay, now again go to the plan view or plinth level. Now if I need to create the beams, what I will do is I will click it here as the go to here as the beams. Suppose I will create beams of 400 by 600 beams. Then what I will do is I will click it here. This is for the columns and this is for the beams. Beams, go to beams 400 by 600. Now I can select suppose I want to create beams from here to here. See, in this manner I can create. By simply clicking it here, I can create the beams, or I can draw manually. If I will click it here, the beams will get created. Suppose I want to draw from one point to another, then for that I can go to, instead of this I can go to here and I can select here 500 by 400, and I can draw manually from, suppose that is from here to here or here to here, then here to here. So this is the manual way. Or again go to this one and click it here, or box it. See, all beams are being created in all stories. Now again I will go to the 3D view. See, now full frame is being created where beams and columns are being created. Now I can also even go to the rendered view by clicking it here. I can use the extruded view. See, beams and columns all are being created. This is how my beams and columns are all created. Even I can go to the elevations and I can click it here. So this is the elevation view, or I can switch to the rendered view, and even I can watch the numbering of this beam in these columns, all the columns. Suppose for that you have to click it in this tick mark, and you can go to the spatial effects. See, all these are properties are present. You can go to object orientation, frames. Shell means slabs, frames means beam and columns, shell means slabs. I can go to the unique names, apply. See, the unique names are 26 to 30, 29, 28, 27. So these are the unique names which are created for all the columns. 31, 35, 34, 32. So unique names are being present for each and every levels. Okay, so after that again go to the plan view, to the plinth level. Now let me create these slabs. For that what I will do is I can click it here, quick draw floors. Here I will select the slab as 150 and I will click it here. In this manner I can create the slabs. Okay, suppose a slab is of different manner, then I can click it here. Instead of here I can also click this one and I can click as slab 150. Then I can left click and stretch and then leave it, or I can click it here. For this one what I need to do is I have to click left click once, then 2, then 3, then 4, then 5. In this manner we, by the help of these three things, we can create the slabs. This is the quick manner. Okay, now again let me go to this portions, then section properties, then slab. Here I will create two type of things, one way and two way. I will click it here. After clicking it here I will create the one way slabs and two way slabs. Suppose I will click this is the one way, this is the slab 150 two way. Let me create as two way slab. Two-way slab means in which the major reinforcements are provided in both the primary reinforcements are provided in both the x and y direction. It is two-way slab in which Ly by Lx is less than equal to 2 are two-way slabs, and in which Ly by Lx, Ly is the longer side by the shorter side, its ratio is greater than 2 are one-way slabs. I will click it here. I will add a copy of property. Then here I will click for this slab one, because there are two type of slabs which we have to create. You can either give the slab thickness as 150 or 200, and slab 150 one way slab. But for one way slab you have to provide as cell thick, and there is no requirement of any shell, sorry, not in cell thick. I have to go to the membrane and for the membrane you don't have to give any property. Simply you have to click on membrane and slab 150 one way. slab, and here you have to check this one, use special one-way load distribution, and click OK. So one-way slab and two-way slab. Here in this slab, ly by lx, each ratio will be less than 2. So this one is the one way. For that I will click in this slab, I will right click it, slab 152 way, instead of 2 way I will change it to 1 way. See, I have changed it to 1 way, but reinforcements here direction is showing in the longer direction. So I will click it here and I will again right click it. As I have changed it to 1 way, I have to even create the reinforcements in the shorter direction. For that, what I will do is I will change the local axis to 90 degree and click on OK. See, now the reinforcements are changed in the shorter direction, not in the longer direction. This is how I have to provide the one-way slabs as well as the reinforcement. Or you can simply change it by clicking in this manner. Suppose I want this slab and this slab to be created as one way, then I will click this two slab, I will go to assign shells slab sections, two-way, apply. Sorry, not two-way, one way. Again select this, assign frame, shell slab sections, one way. Rest are two way, but this two are I have created as one way. Again I have to change the axis 90 degree. Again right click, change the axis as 90 degree. In this manner I can change it. Again all these slabs are also one way. So select these slabs, again go to assign frame, shell slab sections, one way, apply. So this is the shorter direction, so here the direction is this one. Okay, so in this manner we can provide the slabs. Now let me go to the 3D view. So this is how the full frame is being created. So now let me go to the base. In the plan view, let me go to the base and click on OK. Remember that in the base, now click on one story and delete each and every slabs, because in the base level the slabs are not present. It should not present at the base level. After that you have to select all the joints, and after selecting all the joints, now you have to provide the, go to the assign and click on joint, then restraints, then fix support and click on apply. So now all the supports are created as the fixed support. Now again go to the, this is the base means the supports. Now go to again the plinth level. In the plinth level also the slab should not be present, because in the plinth level the only plinth beams are present. So now delete, select all the slabs and delete it. So now again have a watch to the 3D view. See, in the bottom level there is no slab, because in the bottom level the supports are present. This is the plinth level, here no supports are present, here no supports, here no slabs are present. So this is the ground floor, this is the first floor, this is the second floor, and this is the third floor. Okay, roof, and I have created the upper floor as the empty. Suppose one staircase is present in this level, then I can tell the upper level as the empty. Suppose this one is the empty, and so for that what you need to do is you have to go to the keep it as one story, delete all this. So this is the Mamti which I have created. Now go to again the 3D view. So this is how it looks like. So this is the top view. Let me go to the 3D view, rendered view. For that, click it here, extruded view. So this is how, these are the various basic steps which you need to do. So in this video I have told about how to define the loads material properties, how to define the material properties, how to define the section properties, how to create the beams, how to create the columns, and how to provide the slabs, then how to assign the supports, how to assign the supports. Okay, so in my next video I'll be telling about how to provide the loads and how to provide the secondary beams. Okay, so hope it's clear to all of you. So if there is any kind of doubt, then you can ask me in the comment section. And thanks for watching my video. Have a great day.